Perfect. Hi, everyone. My name is Renna Shaw, and I'm originally from Toronto. So this weather isn't really something I'm used to, but I'm a data scientist by profession, and I also teach at the University of Toronto. My passion is analyzing data, business insights from it, and that's precisely what today's session is about. The title of the presentation, so I'll first be giving you a presentation, maybe about 10 minutes long, and then I'll go into a very interactive piece of code. The title of my presentation is pretty interesting. It's called What's Keeping That Train? Here are 16,000 reasons. Now, by the time I finish the presentation, so in about 10 minutes of time, you're supposed to try to tell me why did I name this particular presentation like this, like what's keeping that train, and what does that number 16,000 really stand for, okay? So in terms of open data, what I did was I went to the TTC website. The TTC, by the way, stands for the Toronto Transit Corporation. So buses, streetcars, the subway, all of that is covered under TTC data. So I analyzed 3 types of TTC subway data. So we're talking about the underground system. And there were 5 business questions that I answered, and I'm going to show you the results of those. Now, for those who aren't familiar with the city or aren't familiar with what the Toronto subways map looks like, you can see a few terminal stations over here. For example, there's Finch, there's Kipling, there's Vaughan, and there's a reason why I'm mentioning these stations. So pay attention. And it is this extent of stations that I try to analyze, okay? Now, as you know that there are a lot of delays that occur, give me a second. So the 3 types of data sets that I focused on, and this was all pertaining to subway data. One was metadata, and we had about 10 columns. And what does this represent? It represents a particular point of delay. For example, if an instance of a delay or an incident of a delay occurred at a particular date, maybe the 31st of December 2016. So the date that occurred and the time that occurred was captured in a field called date. So date and time. There's also the day, for example, Saturday, the station. Now, this is very interesting. The metadata, or the raw data, as I'm going to call it in my actual code, has this field called code. And you can see an example of a value in it. It's called MUIS. Now, this particular column is nothing but a series of abbreviations. Okay, but these kind of abbreviations like MUIS, PUTD, we don't actually know what they stand for, but the TTC is generous in that it provides a separate data set that actually enlists these abbreviations with their English descriptions, okay? This one, don't be confused, it doesn't really stand for minimum, it actually stands for minutes, okay? The number of minutes of delay that particular train suffered, okay? For example, that particular train that was delayed on the 31st of December 2016 was delayed by 5 minutes. That's what min delay means. Min gap is nothing but the time gap, the number of minutes between this particular airing train and the next train, the consecutive train. So what this means is that there was a 9-minute gap between this train and the next train. Bound refers to the direction of the train, like this particular train was northbound. And there are different lines like the Young University line. And then there was a vehicle number. Now, this is the first data set, which is the metadata. The raw DF, this is an example. I mean, this was just like a data dictionary. And here you get to see the actual data, okay, the raw data. So you see the date, you see the day, the station, you see an abbreviation, you see the minutes of delay and gap, and you see a vehicle number. And this is a list of delay codes. For example, EUAC refers to something wrong with the air conditioning. That's why there there was a delay. For example, EUBK means that there was something wrong with the brakes. That is why they had to stop the train and a delay occurred. Okay, so this particular data set called codes DF as in data frame, was what that stood for. Now, the most beautiful part, also the most time consuming part, and the most, makes you want to pull out your hair kind of part about data science is data cleaning. So I would say about 90% of the time is spent in data preparation. So this was one of the steps that I used in preparing the data. For example, the raw data, which looks like this. You see, it has a field called code. But when you look at this with the naked eye, you don't really understand what MUPA stands for. You don't really understand what EUCD stands for. So it makes sense that you transform this data set, the raw data, such that corresponding with every delay incident, like this particular row, you also have the English language description. So for example, if MUPA represents something pertaining to, I don't know, some sort of manual failure, you want that word manual failure to be written next to it, okay? So that it's easier for you to comprehend as a human being. So that sort of merging needs to happen of the two data sets, A, the raw data, B, the delay codes. Okay, so that sort of merging need to happen. And what happened at the end of it is that there were a lot of rows, like see, you can see over here station code. And then I merged this data set where you had the code and the code description. There wasn't really a match that occurred between the code, which is the left data set, like over here, the code column, and the sub-menu code. The sub-menu code is from the right-hand data set, which is over here, the sub-menu code. So because there wasn't really a match between the left-hand data set, which is the raw data, and the right-hand data set, which was the codes data, the abbreviations data, what we had to do is this really doesn't add any value to the merged data set. So I had to drop all those rows where the code description was null because it's not really providing us any match. So that way I had to create a clean data frame. I also created a delays data frame by applying a couple of filters. So I made sure that the following kinds of rows were dropped. Now look at this particular row, the one that's marked with an index of 2. It says that the minutes of delay was 0. And the gap, the number of minutes of gap was 0. Now, really, if a particular train has stopped and there's a gap of 0 minutes, I mean, either there's an accident bound to happen or the data is wrong somehow, or this is not the kind of data we're trying to analyze. So I just made sure that I applied a filter where there was, there was a greater than filter applied to the gap, the minutes of gap and the minutes of delay. Okay, I dropped these kind of rows. Now the kind of results. So there were a few business questions I was trying to answer. Number one, I was trying to analyze the data on a yearly basis, so the monthly basis of a particular year, and I wanted to find out in which particular month do the longest delays occur. So for that, after analyzing, I found that it was around the month of May where the longest delay occurred, and that was at about 9 minutes of delay. On the contrary, the shortest delay occurred in September, okay, with about 5 minutes of delay. Another business question that could be asked is, what is the most prominent cause of delay? What is the most prominent cause of delay? And I don't know what this speaks about us Torontonians, especially us as passengers, but it means, what we analyze from the data set is about 1,000 delay incidents occurred because of disorderly patrons. Okay, so this was the highest or the most frequent cause of delay. Another business question that could be asked is, what was the cause that caused the longest delay duration? So this is different from the previous question, because the previous question is which delay cause has the highest incident count, whereas the next question is about the duration of delay, which cause of delay has the longest duration. And as expected, the delay that's marked as priority 1, which is whenever a train comes in contact with a person, that's when the longest delay occurred. Okay, and maybe about 1.5 hours of delay occurred when the train comes in contact with a person. The fourth business question that I tried to answer is that on an hourly basis, so in a 24-hour system, are there specific hours, are there specific times when delay incidents, the number of delay incidents are the highest? And when you look at R15 and R17, so 3 p.m. and 5 p.m., that is when the most delay incidents occur. And this is done on a yearly basis. Okay, so when you see 400, it means 400 delay incidents occurred over the year at whatever 3 p.m. And the last question, try to connect the dots now. The last question is which stations have the highest number of delay incidents? Like, are there any specific stations where extra TTC personnel need to be deployed, or maybe extra workers or maintenance men need to be present? When I analyze the data, these were the 5 stations that were the biggest culprits: Vaughan, Finch, Kennedy. If you're not familiar with the names, it's fine. But you can see all the delay incidents in descending order. Now, what I want you to do is connect the dots, okay? I'm going to give you 3 names: Vaughan, Finch, Kennedy. Okay, and I'm going to take you back to the diagram of the subway map. Is there something you notice about Vaughan, Finch, and Kennedy? Okay, yeah, he's right. He said they're at the end of the line, which means they're terminal stations. Now, there's a reason why that occurs, okay? Why do the highest number of delay incidents occur at terminal stations? It's because it's usually once the train comes to a complete halt that, cleaners, etc., enter the trains to just check the entire train. And they, at that point of time, some sort of mechanical faults are found. And at that point of time, a lot of cleaning or other uncleanliness incidents are found. Like, for example, sometimes people have vomited there, people have urinated there, etc., etc. So when you have those kind of things happening, the delay incidents, or the number of minutes that are spent delayed at those kind of stations, terminal stations, will lead to a high delay incident count. Okay, so this is the reason why terminal stations have these kind of delays. So those were the 5 business questions that I answered using TTC's open data. And this one, well, if you want to connect with me on LinkedIn, here's my URL. But this ends the presentation, and I will soon go into the interactive part, which is in a Jupyter notebook. Okay. So I'll give you about 1 minute of time to maybe ask any questions, or maybe drink some water or anything, and I'll just open up my Jupyter notebook. Okay, and I'll share the screen for that. I can take any questions. Oh, good question. You know what? Can I open up my Jupyter notebook really quickly? And maybe then you'll come across that kind of figure, and you can tell me, why did I say 16,000 reasons? Okay. He actually answered it, huh? So the first benchers, as usual, are just killing it. So he said 16,000 valid rows. And the thing is, when I opened up the raw data frame, let me see if I can find it up. So this was the raw data frame. And when I opened it up and cleaned it up, I'm so sorry. How do I deal with this? I'm just trying to share my screen, huh? You know what? Because in Eglinton right now there's a lot of construction work going on line 3 to construct line 3. That's the reason why there's a lot of delay over there. In fact, every weekend you can find a lot of delay incidents in Eglinton. Yeah. So as the gentleman in the first row said, and I'm somehow not able to share my screen at this point of time, but in the raw data frame, let me see. Just trying to share my screen. Okay. Do I need to?
We do have a computer expert sitting somewhere in that area. Won't point anyone out, but
Okay. Let me see
which screen are you trying to share?
the presentation.
Yeah, there you go. Now go back to Zoom. It needs to like rethink.
Okay.
And if you go back, it's usually
But to continue his line of thought, it's just that the raw data frame, the one that had all the details of delay incidents, this particular data frame is the one that had about 16,000 rows. Okay, that's why it said 16,000 reasons for delay. Okay, 16,000 points of interest that have been captured and analyzed. Okay, so at this point of time, I'm going to open my Jupyter notebook, and I noticed that it's about like we've passed about half an hour right now, and it might be too short a period of time for me to actually wait for everyone to sort of be interactive. This is with the code, okay, and execute the code along with me. So I think the best approach at this point of time would be for me to open up a completed Jupyter notebook, like the completed code, and explain my thought process, explain why I've done certain things. And don't worry if you're a complete beginner to data analysis, to coding, to Python. I am going to go over a few Python basics before we actually jump into the analysis. Okay. So give me a moment to pull up my notebook that contains the code. I didn't try. So at this point of time, I think we can start with the actual code. I'm going to begin by giving a little primer on Python. So before I actually begin with the code, I want to let you know that in case you want to follow along all the cells, there's this URL that I'm going to paste in the Zoom chat for all those who are attending virtually. I'm just going to write completed code. I'm going to paste a link in the Zoom chat for all those who are attending virtually. And I'm also going to paste it over here. This is where you can follow along. Don't really bother too much about the image that I tried to paste in line. So, the presentation that I showed you had the subway map. I tried to embed the subway map, but because it was in a local folder, that image didn't really come up. But we'll focus mainly on the cells, okay? The cells that contain code, not so much on images. So if you want to follow along, you can actually paste this one. It's https tinyurl.com/Renna cods 22 Python. And in between these words, there's a hyphen. So Renna hyphen cods 2022 hyphen Python. So if you type this particular link, you'll reach my GitHub gist that contains all the code. Okay. And if you want, I can organize this code a little more neater later. So in terms of the actual code, I want to begin with a few Python sessions. And I think I need the use of both hands this time. So I'm going to put the mic over here. Now, with regards to Python, I'd first like to begin with the data types. And I want to let you know that within Jupyter Notebook, or for example, Colab notebooks, Jupyter notebooks, Colab notebooks, these are platforms where you can write little bits of code, test them out, see the visualizations, and build your code incrementally. Okay. So data scientists use notebooks, be it Jupyter notebooks or Colab notebooks, a lot. So in case you want to open up maybe a Colab notebook, you don't need to already have installed Python. You don't need to have already installed specific packages. All you need to do is just type Google. Let me see, this one's opening. Just type Google Colab. Once you do that, and the internet is a bit slow, so just bear with me. Once you do that, it's going to ask you for your Google account credentials, so your username and password. Once you enter your Google username and password, let me close this. You can click on New Notebook and wait for the new notebook to load. Okay, and let's create a new notebook. Let's call it, I don't know, my first EDA. EDA as in exploratory data analysis. Okay, let's call it my first EDA. And what you need to do is you need to connect, okay, to the server that Google has hosted. Once certain memory is allotted to you, that's when you can actually write code and run it. So now that you see this check mark, that means that your code or your notebook is ready to for execution. So I'd like to begin by giving you a few shortcuts. For example, if you want to type something, for example, if you want the output of 3 plus 7, you type that out. And if you want to run that cell, this little box that you see, this rectangular box where I've typed 3 plus 7, it's called a cell, C-E-L-L. If you want to run a cell that contains code, you have to use a keyboard shortcut called Shift Enter. When you do that, the output, the cell is run and the output is displayed, so 10. So you use Shift Enter to run the cell. And basically whatever is inside a Colab notebook is also mimicked in a Jupyter notebook. So this is for people who don't already have Python installed, Google Colab. In my case, I already have all the packages I need. I have Python installed on my machine. So I'm not going to work on a Colab notebook. I'm going to work on a Jupyter notebook. Okay. So that's what I've opened right now. And this is where I'm going to write. I'm going to continue with the session. Okay, so the first thing I'd like to begin with is data types. And within data types, you have different kinds. For example, numeric data types. I'm just shifting to a markdown cell so that I can write comments, okay? Numeric data types. And over here, you have examples like ints and floats. Just trying to create a comment. Okay, so numeric data types are ints and floats. Ints, for example, are 3, and floats would be 3.0 or 3.14, the value of pi. So they're very useful when you want to compute something, for example, the mean or the median of something. The next kind of data type is text. And for this, textual data types would be strings. So let me convert this into a markdown cell first. Textual data types would be strings. Now, what do I mean by that? If I have anything enclosed inside quotes, it could be a single quote or a double quote. For example, the airline that I flew into Yukon with is Air Canada. So this is enclosed inside quotes. As a result, this particular value, Air Canada inside quotes, is a string. Okay. I also want to let you know of something else, and this might be a little counterintuitive, but bear with me. The flight number that I flew in on, I don't know why this is happening. Give me a sec. The flight number that I flew in on is called AC 1899. Now you see characters over here, like you see alphabets A and C, but you also see a bunch of digits. I want to let you know that you shouldn't be confused by this. Just the fact that it's enclosed within quotes means that it is a string. Okay, it's of a string data type. Now what usually happens is, and if you actually try to use the Pythonic function type, it is going to tell you that it is of a string data type. Strings, or for that matter, any value, can be stored inside variables. Variables are nothing but containers. So for example, If I say flight number, and variable names can be of your choice. If I create a variable named flight number, and I assign the value, the equal to is not so much an equality as it is an assignment operator. If I assign the value of AC 8099 in it, okay, what I've done is I've assigned the value of AC 8099 to a variable named flight number. Now that this variable has been created, I can do anything with this variable. I can call it, I can create functions using it, I can transform it, uppercase, lowercase, whatever. So if I actually reference the name of this variable just by calling, just by mentioning the variable name, I run the cell and it displays the value that was stored inside that variable. Okay, so this is one way we can create variables and reference variable names. The third topic that I'd like to go on is some built-in functions which you'll find very useful. I've created a markdown cell and I'm going to talk about built-in functions. I'm only going to show you one right now, but as I do the analysis, you'll encounter more. There is a built-in function called len. Any idea what len stands for or what it could do? Number of characters, exactly. And you know what? In real life, or rather in industrial use, we spend a lot of time Googling stuff. Nobody knows everything at the top of their head as a result. As it is, the language is changing constantly. So if you are not sure about a particular function, all you do honestly is Google it. Okay. And the Python docs are so comprehensive. They let you know whatever you need to do with that particular function, with that particular methods. Okay, so docs.python.org is your best friend when it comes to any programming queries. So you can search for a particular function that you're interested in, and you can see and you can have a look at the syntax. Syntax is basically the rules how to use that function or use that particular language. You'll see that there's a function called len, and you need to pass something inside it, and that is the variable name or the string name that I want. So for example, in this case, if I pass the variable name flight num to the function len, what do you think the output should be? 6. Okay, let's actually execute it using shift and enter, and 6 it is. Okay, so all you do is for the len function, you use the docs. It says you need to write len followed by a pair of parentheses, and you need to pass a particular object. Okay, you need to pass an argument that could be a string, that could be a list, that could be just about anything. So this is the example of a built-in function. There are also certain methods. Okay, there are also certain methods. Now, let me do something. Let me create a variable. Let's call it conf name, like conference name, and let me call it cods. As you can see, all of this is in lowercase. If I use a method, now I'm going to show you. I'm going to call conf name, and I'm going to use a method. Let's call it upper. Any idea what that is going to do? Uppercase. You're right. So I'm going to execute this using shift and enter, and you can see the output. Cods, like the whatever was inside this particular variable got converted into uppercase or capitalized. So this is a method. And you know what happens in real life is you won't necessarily know all the built-in functions, all the methods, etc. So how you would go about doing it is you actually will have a task in front of you. For example, you don't know how to convert a string into uppercase. So you'll type, this is what you'll Google: Python convert into uppercase. This is what you will Google, and this is how you find out answers. You see, the first result that came up says In Python, upper is a built-in method used for string handling. And if you want to understand how to use it, you can really click on any of these resources to find out how to use. So I'm not just giving you fish, I'm also teaching you how to fish. Okay. So for example, if you want to see how to use the method upper, okay, upper and lower. So you have a variable name and you've stored the value inside it. And when you when you call that variable dot upper, that's how you get the output required. Okay. So there's always syntax examples of how you can go about doing things. Now that we've finished um, a few methods, a few functions. Oh, there's one more thing I wanted to teach you. Just mention something about booleans. Now I did mention numbers and like ins and floats. I forgot to mention boolean. Okay, guys, maybe if you've studied circuit theory, have you come across the word boolean? Do you know what that stands for? What does it stand for? You can give me an example of a value, okay, that represents booleans if you're not able to define it as such. Like perfect, true, false are that is exactly what boolean stands for. Okay, so if I were to use it, maybe over here, I'm going to use the variable conf name. Okay, and if I use the method ends with, so this is me checking if the value in a particular variable ends with a certain character. So let me pass that character. Let me say conf name dot ends with s. Guys, what do you think? Will this return true or false? I mean, this is the assignment that I did. I don't know why my trackpad isn't working too well right now. This is the assignment that I did, and I called the ends with method on this. So do you think this is going to return true, or do you think it's going to return false? Perfect. It's going to return true because the value inside conf name, which is called, ends with an s. Okay, so this was me using the concept of booleans. I think 2 more minutes and we can actually move on to the analysis. Okay, I wanted to mention a concept called libraries. I will create a markdown cell and not a code cell. I wanted to mention the concept of libraries. Now, Python has many famous libraries for data manipulation. One of them being pandas. Pandas is it's a very frequently used library, so much so that the standard practice is that whenever you create a Jupyter notebook, Colab notebook, whatever, by default you write import pandas as PD, import numpy as NP. Irrespective of whether you end up using other libraries or not, you always write these two statements at the top. Okay, so pandas is used for fast processing of tabular data structures. Okay, if you want to analyze time series data, if you want to basically work with data frames, I'll tell you what they are. You'll use pandas, you'll import the pandas method. There's another method called numpy, which is very useful for scientific computing, and this is something we're going to use today. It's called matplotlib. Okay, matplotlib is a library used for data visualization. Okay, so what really happens, what are libraries? Basically, there are Python developers working all the time, continually publishing open source code. So functions related to a particular area, for example, matplotlib is related to the area of data visualization. Those particular functions are grouped together into a library, in this case matplotlib. Okay, so libraries, when you import them, it just makes your life easier because you don't have to reinvent the wheel. Okay, so if using matplotlib you want to set the value of the x-axis using a matplotlib method. So matplotlib will have a method that sets the chart title. Okay, so you will call that function plt, which is an alias, a short form of matplotlib, and then you'll call the function that's associated with matplotlib's chart naming capabilities, and then you will name your chart. So libraries are a very important concept in Pythonic data analysis. Now, a data frame, since I mentioned libraries and pandas, right? A data frame is nothing but a 2D data structure, okay? A two-dimensional data structure that's nothing but a combination of rows and columns. Data frames are what pandas mainly works on. So I'm just going to write the word 2D over here, and I'm going to write rows and columns. And I guess the last topic before we jump into, let me create a line break over here. The last topic before we actually jump into the analysis is how to access specific columns, specific rows, okay, of a data frame or of a table in this case. Accessing rows and columns. Sorry. Now, suppose you have a data frame that has multiple columns, like, the raw DF column, it had columns called station, it had columns called, I don't know, it had columns called vehicle number. If you want to access these two these two columns in the data set, and maybe not all the columns, just these two, what you would do is the columns of interest, you will actually enclose them within a list. A list is mentioned by using square brackets, okay? The columns of interest you will mention using square brackets, and maybe say, create a variable called needed columns list. I have a habit of mentioning the data structure at the end. So at the end, I mention a list, a dictionary, a tuple, or whatever. So, and then what you do is you will access the data frame and you will use square brackets. And within the square brackets, you will call this variable name that contains only the variables, the columns of interest. So df needed columns list. Okay, now imagine this data frame, originally the dimensions were I don't know, maybe 2000, 16,000 rows and maybe 10 columns. Let me do something. Okay, let me call this df2 or new df. So what I did was, the original df had dimensions of 16,000 rows and 10 columns. I now created a variable, a list variable called needed columns list, and I'm basically subsetting the columns that I'm interested in. And I'm basically using square brackets to access only that subset. And I'm storing that value inside a variable called new df. You know what's going to happen when I try to write new df dot shape. Now shape is a method that's used on a particular data frame. It gives you the dimensions of a data frame, basically. You know what it's going to output as the answer? Oh, sorry. It will output 16,000 rows because we didn't try to subset rows. But in place of 10 columns, it's only going to output 2 columns. Okay, it's only going to output 2 columns. So accessing, specific rows and columns using the square brackets is very important, especially if you have a humongous data set to work with, but you want to try certain functions only on small bits of the data set. So you might want to access them. So that's one way that you want to access columns. So I'll just mention this as columns. A way to access rows, if you want to access, say, the first row of a data frame. Oh, I probably forgot the most important thing. Python uses zero-based indexing, okay? What it means is that the first row is indexed as 0. So suppose there are 10 rows in the data frame, it's going to be called 0, 1, 2, all the way to 9. Okay, it's not going to be 1 to 10. The indexes will be 0, 1, 2, all the way to 9. So if I mention df, so I'm calling the data frame dot ilock, And I mentioned the index number inside the square brackets. This would actually help me extract. Hello. We have six. So, sorry for the interruption. There was a bit of an echo. df.ilog, and when you pass the index number inside the square brackets, it would access that specific row. Okay, so the 0th index pertains to the first row. Now, this actually, let me create a line break. This actually completes the Python 101 that I wanted to cover. The meat and potatoes are actually in the analysis of the TTC dataset. Let me see if I can do this better. I'm just trying to format this a little better. Okay, fine. Now, with this, we've actually finished part 1, which was Python 101. We can now move on to part 2, which is the analysis of the TTC dataset. Okay. As I mentioned, you can follow along using this tiny URL link. This is where all the code is. So let me see right now. If you were to go to the tiny URL link, this is where I am. Okay, this is me providing you a pointer of where I've reached so far. It's part 2 analysis of the TTC dataset. We're now going to import certain packages that we need. As I mentioned, you always mention import pandas, import numpy. That is standard. Because of the shortage of time, there's a little caveat that I wanted to mention. Because of the shortage of time, you will find that the data set that I've used is a bit modified, meaning I have already partly cleaned the data set and used that partly cleaned data set to conduct today's analysis, okay, the analysis used for the workshop. Now, the reason is the actual data set was much dirtier and would take way longer than 3 hours for me to explain the cleaning process of. So I only did, I only retained that kind of dirt that could be tackled within 2.5 hours, 2.5, because there's a networking break. So the reason that the point that I'm trying to drive home is, if you log on, if you visit the TTC website and try to download the 2021 files yourself, you will find that that data set looks a bit different from mine. Okay, and that's because my files have been modified, as in partly cleaned already, just for the purpose of this workshop. Okay, so let me actually work with this just in the interest of time. Let me not actually, no, I'll still have to do something interactive. So you know what, I'm copy pasting this just to save time. So what you do is you import the libraries that you need: pandas for fast processing of tabular data, numpy for scientific processing, and matplotlib because we are creating graphs. The graphs that you saw at the end of my PowerPoint were all created using matplotlib. Okay, this particular one, import svg, was because I wanted to embed the subway map, which is an image file. That's why I wrote import svg. So let me execute this using shift and enter. There it is. Now, in case anyone's interested how to embed images, like in this case the subway maps image, you will have to, let me just create a cell, a markdown cell. You'll have to use a markdown cell for this. Okay, so not a code cell, a markdown cell. In my case, what I've done, and this might not pop up, let me see if I can share. Let me see if I can share something a little different. New share. I'm just trying to show something a little different. Okay. So the TTC subway map was an image file that was stored in my particular folder. So what you have to do is you have to point to that particular folder, mention the file path, and that should do the job. So let me see. Okay, sorry, this should be a markdown cell. And that is how you embed an image. Okay. Now, step 1, reading all the data sets. In this case, reading 3 data sets. Sorry. I didn't resume share, right? Sorry. This is me. Yeah. Perfect. So when I embedded this piece of code that mentions the file path and mentions, the width and the height of the image, I embed this in a markdown cell, okay, not a code cell. That's when the image gets embedded. Sorry, I don't know why this is happening. That's when the image gets embedded. Now, the first step is to read the 3 data sets. I'm going to read the 3 data sets as data frames, okay? So there was a raw data frame that contained all the 16,000 delay incidents. There was a codes data frame that contains the abbreviations and the English language description. And there was a data dictionary. I'm going to import all of these. So what I'll do is I'll mention PD. Oh, I may have forgotten to say this, but at the start I mentioned, sorry, I don't know why this is happening. I mentioned import pandas as PD. PD, NP, these are nothing but aliases, okay? And matplotlib, I imported it as PLT, right? Matplotlib.pyplot. Aliases are nothing but short form. So instead of, whenever you want to call the matplotlib.pyplot package, instead of writing MAT, instead of writing MAT, PLOT, matplotlib.pyplot, all you do is if you've created an alias, you can just write PLT and get the job done. PLT dot whatever, naming the x-axis or whatever. So in a similar fashion, PD dot read Excel, the files that were displayed on the TDC website were Excel files. So pandas has a method called read Excel. And how do you find that out? You can just say pandas Excel files. And it says that the method that you need to use is read Excel. So that's how you find out what methods you need to use. So what you do is you mention, sorry, my trackpad isn't working too well today. I apologize for that. Oh, it froze. I'm sorry. It froze. This is not what I have up here. It froze for some reason. I'm just trying to get for the virtual attendees, I'm just trying to get a bit of attendance. Assistance. So this is, sorry. Sorry, the screen froze for a bit. So how give me a second. This is a different one that I intended to. Here it is. So I wanted to show you how you would read Excel files using pandas. And you would mention pd.read Excel, and then you would mention the file path of the file that you're interested in. So the raw data file, the delay codes, and the metadata. Okay. and you run it. Wait for, okay. And I just want to let you know that in case a cell is still running, as in the execution is still on, over here where you see the cell number, you'll see an asterisk. The moment you see a number, it means that that particular cell has finished executing and you can move on to the next cell, okay? Now, if you want to just have a bird's eye view of the raw data frame, let me, we might want to find out the dimensions of this data frame. And you, the gentleman in the first row was right, 16,000. Okay, and 10 columns. Pandas has a few methods called head and tail. Head gives you the first 5 rows of the data set, and tail the last 5 rows. So if you write raw df dot head, it would give you the first 5 rows, so you can know what you're working with. But you can also mention a number of your choice. Maybe if this is too long for you, you can mention 3, and that would only mention the first 3 rows. Okay, so I wanted to bring that to your attention. Head is used very, very often. Shape, head. If you want to, like in this particular case, if you want to modify, if you want to have a list of all the columns, okay, you'd mention raw df dot columns. That would give you a list of the columns you are trying to work with. So you don't have to actually type the column name out, especially if case is a problem, okay, uppercase, lowercase. You can just copy paste it from the dot columns output. Now, let me see. When I look at delay minutes, gap minutes, when I'm just trying to form a few theories, okay, let me go back to head and not just 3. I see something very interesting, and this is why Jupyter notebooks are so useful as opposed to VS Code or something like that. It's because Jupyter allows you to trail, I mean, your train of thought. It allows you to actually write that down, write comments, and create visualizations in line. Okay. Now, over here, I noticed some peculiar things. Rows indexed 3 and 4 have a vehicle number 0. Now that seems very odd. You usually should have a finite value for vehicle number, but not 0. I also notice, yeah, I noticed that the first row has a gap minutes value of 0. Really, like 2 consecutive trains, no gap at all. That seems a little fishy. So if you find something peculiar or weird, in this case, again, it's the first row that's the culprit. It says delay minutes of 0. If delay minutes is 0, should this incident even be in this data set, in this delay data set, if the delay minutes is 0, if no delay occurred at all? So if you have, if you've noticed something very peculiar, you can actually, and you want to investigate it further without, you know, losing track of the different questions you had, you can write it as a markdown cell, as a comment. Okay. Let me save all that I've done, Control S. Now, I think I've fairly explored the raw data frame. I can move on to the next one, which was the delay codes. Okay, I can move on to the delay codes. Now, for the delay codes, mark it as a markdown cell. As usual, head and shape. Let's find out. So the raw data had about 16,000 rows. Let's see what are the dimensions of the codes. Okay, so there seem to be about 200 different abbreviations. Interesting. What about shape codes? Sorry, what about head? The first 5 rows. Now, this is an example of some dirt that I left in the data. You see that the column names are called unnamed 0 and unnamed 1. And the actual name of the column got shifted below. Sometimes, especially when it's open data, you'll have this problem where the columns are not named properly or they got shifted, etc. So how do you work with this? What we need to do is we need to basically extract df.ilog, extract the value of this row index 0, and make sure that whatever is the content of this row, this ends up as the column name of the codes df dataset. Okay, that's what we're trying to accomplish. So step one, what we're trying to do, extract the contents of row index 0. So for that, what we'll do is df.ilog. So codes df dot ilog. This is us extracting row index 0, which is the first row. Let's just see whether it gives us what we want. Yeah, it gives us our menu code. It gives us code description. Now, what we need to do, we need to make sure that this becomes the column names of this codes df dataset. For that, we will assign, use the assignment operator. We will assign subr menu code and code description to codes, the value of codes df dot columns, the value of codes df dot columns. What this will do is, now if we try to adopt, call the head method, HEAD, after this transformation, you will find, oh, okay, that sub R menu code did end up at the top, okay, did end up as a column header. However, it's not fully clean. This still remains, right? So we're going to tackle with that. We're going to tackle that right now. So what we need to do is whatever first row exists, we need to drop that. Okay, so we're going to use what is called the drop method. So codes df, whatever value of codes df I have right now, where sub menu code is repeated twice, I'm going to use the drop method over here. And what am I trying to drop? I'm trying to drop the first row, which means index 0. But this is very important. How, okay, I mentioned index 0, but how do I know, how does Jupyter know that it's the row that I'm trying to drop or it's the column that I'm trying to drop? It knows if you mention the value of axis. Okay, so if you write axis equals 1, it's going to drop a column. And which column? The 0th column. However, if you write axis equals 0, it's going to drop rows. And which row? The 0th row. I mean, the 0th index row, which is the first row. Okay, so if you want to mention that, hey, it's rows that I'm trying to drop, mention axis equals 0. Okay, and what we usually do is in place equals true. In place equals true is an argument. And you know what, how do I find out like these are the parameters used? It's very simple. I just mention pandas. Let's say it's the drop method that I'm trying to find all the parameters for. You can either go to the documentation here or maybe in W3 schools. That is also a good resource with lots of examples. Okay, so when you use in place equals true, you're modifying the existing data frame. Okay, you're modifying the existing data frame. So using this, you know that in place is a parameter that you may use in the drop method. So I'm going to say, yeah.
Question is, even in our studio, you can do a question mark function.
Huh.
Get a help file. Conveniently decide. I'm assuming there's something similar.
Oh, you know what? There's actually a keyboard shortcut for it. There's actually a keyboard shortcut for it. Give me a one. Like the help. Give me 1 second. The help.
Yeah, instead of having to Google it, I'm assuming there's a help.
Yeah, there is. Let's see. There is a keyboard shortcut for that. Give me a second. Maybe it's the tab. Following the dash after typing the name of whatever, following the dash character, hit tab. Let me try it out. Following, I'm not too sure over here. Since what I end up doing is normally Googling it up. I haven't tried to pull up that sort of tooltip or that sort of help tool. Let's see. I know that math.sin. One second. No, I'm not too familiar with how to make the keyboard shortcut work, but pretty sure there might be a query in Stack Overflow that actually addresses this. So that might be one way. That might be one way. So so in place equals true. Yeah, I'm on the correct screen. So what this does is it makes sure that the existing first row is dropped. And I execute this and look at the code's data frame now. You see that we only have the things we want, okay, which is just the list of abbreviations. Okay, so now that we have, and it's 200 rows, 2 columns. Now that we've finished looking at the second data frame, we might want to look at the third. So let's delve into metadata, and it isn't too much really. It was more like a data dictionary. So we might not work too much with it. So the metadata data frame, I'm going to mention the usual methods like shape and head. Yeah, just 10 columns and 3 descriptors for it. It's not too important. If you want to get an idea of what the first few rows look like, maybe just 3 rows. Yeah, I mean, might as well display all. So if you want to know the content. So yeah, this is exactly what you saw on my slide, okay, on the PowerPoint presentation. So now that we have an idea of what the data set looks like, it's actually time to prepare the data, okay? So we have imported the data and it's time for step 2, which is preparing the data. And this is where the real work happens. Okay. 2:18. We are 12 minutes more and we'll be going for a networking break, I think. So let's see how much we can finish before that. Now this is where we end up having to join. Now, if you noticed, raw DF was very unyieldy in the sense raw DF has a column called code and you see a bunch of abbreviations, but the human eye doesn't really understand what these abbreviations stand for unless you have the other data set, the codes data set that actually has the English language description next to it. So you want to be able to, for each instance over here in the raw DF data frame, you want to display the associated English language description from the codes DF. So what you're going to do is you're going to try to join 2 data frames. Okay, you're going to try to join 2 data frames. So let's see. So in the same data frame, what you're going to try to do over here, I create this as a markdown. For every value of the raw DF's code, you want to try to get the English language description. So you're going to try to merge 2 data frames. For this, I'll use pd.merge. Sorry, my bad. This should be marked down. Sorry, this was an extra column. Escape, and then pressing D twice, the character D is a shortcut to delete the cell, okay? So you want to mention pd.merge, and then you want to mention the 2 data frames that need to be merged. In this case, the raw data frame that contains the 16,000 incidents and just the code abbreviation. So that's on the left side, okay? This is similar to a SQL join. So you have a table on the left, you have a table on the right, same thing. And then on the right side, the second data frame that you're mentioning is codes DF, which contains the full form. And if we take a glance at codes DF, we want, this is using the principles of SQL. We want to perform what is a left join, which means you want to retain all the rows on the left hand side table and get the corresponding match from the right hand side table. And how do you want to, what is the column on the left hand side table that you're trying to perform the join on? That column is called code. So I'm going to write left on code. I'm going to take care of the case. Okay, if code was everything in capital in the column names, I would follow that. Now on the right hand side, if this helps, I'll create a new cell. Escape B is the shortcut to create a cell below. Okay, I might as well give you a glance of the codes data frame just to know what is the column we are joining on the right hand side. Okay, so abbreviations are present in the code column on the left table and in the sub R menu code column on the right hand side table. So that's what I'm going to write inside right on. Okay, I'm going to write sub R menu code. So this is what needs to be matched from both the tables. And the last thing I will mention, okay, I need to assign this first of all. So let me call this maybe a merged file or a raw merge DF. Okay, so remove the extra. And once this is done, let's see the output. Let's see the output of merging two tables. Okay, so I might have put an extra space. Yeah, cool. So we have the left table as it is. Okay, so line, vehicle, all belongs to the left hand side table. But you see two extra columns, sub R menu code and code description. Remember, these are from the right hand side table. So this was us merging two tables. And if you notice, I mean, if you try to make sense of what this means, UCO refers to some sort of delay caused due to couplers. EUCD is some sort of delay. I mean, the abbreviation is consequential delay. MUIS refers to injured or ill customer. So, okay, we're on the right track. Okay, we're on the right track after merging the two data frames. So let's see, after merging the data frames. Now, initially the left-hand side had 10 columns, right? The left-hand table. Let's see, after adding two more columns, it should be 12. Let's verify. So the raw merge DF, if I add, if I use the shape, on it, it mentions 12 because 10 plus 2. Cool. So the next thing, now that we've merged two data frames, what's interesting to note is that some of the columns, we might want to find out missing values, right? So let's write raw merged df dot info. This is just to find out missing values. So on the whole, it should have some 16,300 rows. And if in a particular column, there are values less than this figure, 16,300 something, it means that that column has missing values. Okay, so let me show you. Okay, so it says that the data set as a whole has about 16,300. And what's interesting is that the columns from the right-hand data frame have fewer than the 16,300. So this is about 16,000. This is also about 16,000. So it means, and bound is also a lot of columns, a lot of values are missing. It has about 12,000. So we know that bound isn't that important of a column to us. So we're not really bothered about missing values here, but missing values in sub R menu code and code description, they do matter to us. Okay, so this needs to be investigated further. And that's what I'm going to do. Okay. If you want to find out which are the values of sub R menu code? Like, is it MUIS? Like, whatever. Which are the values of code that don't really have a matching description? The match is formed by the merge, okay, the merge that we did of two data sets above. Then you can probably try to find out. Let me see. If you're trying to do this, you're trying to find out the missing code descriptions, right? Yeah, so missing code descriptions. So in that case, what you do, I do find out that working with 12 columns can be a bit too much. So I'm going to perform a subset of the columns. Remember, I taught you how to use square brackets to subset the columns that you need. So let's see. I'll create a needed columns list and only work with some columns that, a few columns that I'm interested in, maybe station, code, and definitely the last two, because the last two are the ones that have missing values. So station, give me a second. Station, code, and then sub R menu code, definitely, because these have missing values. So definitely need to include this in my subset, and code description. This is what we're after, the English language description. So mention this. Sorry, my trackpad isn't working too well today. And code description. Okay. So since this is the list of the columns of interest, what we can do is subset on only those columns. So the data frame is called raw merged df. Sorry. Raw merged df. I only want these 4 columns. And now maybe I can try to add a filter. Okay, I can probably try to add a filter. Okay, so wherever there wasn't a code, a value of code description, basically the match didn't really work, the matching between two data sets after we tried to join them. So wherever the value of code description is null or nan, I'm trying to inspect those rows. So how do I find out which were the rows that have a null value of code description? This is how I do it. I use the is null method. Okay, I use the is null method on the code description column. So what I do is I'll just copy this case. I'll copy the case from here. And I'll mention the filter. Filters are usually mentioned inside square brackets. I'll mention that this particular data frame for the column code description, I might have already written the codes. Yeah. I only want to extract those values or those rows where the value of code description was null. Okay, where the value of code description was null. So that sort of subset of rows where that had null values of code description, I'm going to assign it to a new data set. Okay, I'm going to assign it to a new data frame. And this time, let me call it NaN descriptions, because there were no descriptions obtained, right, from the merged and data frame. Okay, so let me try. Let me try to copy. Let me try to copy this and see. I'll apply the shape method on this object because that will give me the number of rows. Shape gives you dimensions, right? So if I apply the shape method on this object, it will give me the number of rows, 288 rows that did not have a match in the English language column description. Okay, so what happened basically is, like, if I do a head on this particular one, Oh, sorry. You see, the column code is from the left-hand data frame, the raw DF, but these two columns, sub-R, menu code, code description, is from the right-hand data frame. Even though values, like for every value present in the left data frame, a corresponding English language description was not found. There was no matching that occurred when we try to join on those two data sets. So this is something that needs to be investigated further. How? What we can do is we can try to find out. Now we see there are 288 rows. Cool. But what about the unique values of code that did not obtain a match? We can use the unique method for that. Okay. So basically, if you try to access the guilty column, which is code, and how we do it using the square brackets, and you apply the unique function on it, UNI QUE, and you apply the unique function on it. And what I'll do is I'll typecast this output into a list format. So I'll write list parenthesis. What that will do is inside a list, so enclosed in square brackets, it's going to give me the list of codes that did not have a matching description. Okay, that did not have a matching description. As in, the codes were mentioned in the left data frame, just that when you try to join it with the right data frame, somehow a description wasn't pulled up. So now that we have sort of narrowed down to the guilty codes, okay, to the codes that need to be delay codes that need to be inspected further, we can try to understand why these codes didn't really result in matches. So before I leave you for the networking session, I'll just in a sentence, okay, in a very short form, I'll tell you that the reason why these 6 delay codes, now these are just possibilities and we have to test them, which we will after you come back. One possibility why these 6 delay codes did not produce a match in the code description is because they might have had a different case. Okay, like for example, MUNCA, which is all capitalized in the left-hand data frame, it might be present in the sub-R menu code in the right data frame. So there might be a MUNCA, but maybe in the right-hand side, there might have been M capitalized and UNCA might be small. So when you have differing cases, a match is not going to occur. Another case might be in the right-hand side data frame, there might have been the presence of leading spaces, trailing spaces that will also cause a mismatch or other no matches at all. So that might be a possibility. And the third possibility that we're going to test is that these 6 delay codes that somehow didn't produce a code description were not even present in the right hand side table, in the codes DF table. Okay, so these possibilities are what we're going to check once you'll come back from your networking break. Okay, so we'll come back, I think, at 3 p.m. So I think we are doing well for time. So we'll resume at 3 p.m. Okay, so looking forward to seeing you then. For those watching virtually, we will return in about 25 minutes, which is 3 p.m. Yukon time. Okay. I know. It's okay. You know what? There is so much content. It may have not worked in terms of running over time. It may have not worked if both of us were typing it. Yeah, as it is, like my original intention was to type each and every cell out, like literally everything. But I realized because of the technical glitches, the time that I had on hand was reducing. So I was like, okay, Let me read through some things. Let me read through rather than actually typing them out. Yeah. Okay. So I guess, sorry. Thank you so much for resuming. Sorry, thank you so much for coming back into the rooms and showing your encouragement for this session. Um, to give a one sentence or maybe a couple sentence recaps of where we left off, we're at the spot where we've got a list of unique delay codes that don't really have a match, in the sense we weren't able to find an English language code description for those delay codes. So we're going to try to find out what's so unique about those delay codes that we're not able to find a match. Like, is that a problem we can troubleshoot, or do we have to bypass it or something? We'll try to find out. So let's try to first find out whether these 6 values, the ones inside the list, are altogether absent in sub menu code. Remember, we're trying to compare the value in the code column with the value in sub menu code. So in the original codes DF, we'll try to find out if MUNCA even exists in the first place. Okay, if it does, we'll try to find out why that didn't really produce a match when we did pd.merge. So I guess what we'll first do is inside codes DF. So the right hand data frame was codes DF. Okay, let me create a header, not header, a markdown cell. And what I'll do is try to find out the unique values inside the right hand table, sub menu code. Okay, sub menu code. So escape B, a shortcut to create a cell below. Yeah, so I'm going to try to find out the unique values inside codes DF, which is the right hand side table. And another thing I'll do is I'll try to sort these. I'll basically display these delay codes, sub R menu codes as a list, and I'll display the items of this list in a sorted fashion. Let me see if I closed all the brackets. Yes, I did. I'll try to display the items of this list in a sorted fashion, like A, B, C, D, that alphabetical order, so that it becomes easy for me to check for absent code values. Okay, so depending on the sub R menu code values, we are going to check whether there are absent code values. So what I'll do is run this cell, and it seems the list of sub R menu codes starts with E, and this is all in alphabetical order and goes all the way to T, I guess. So what we'll do is we'll try to compare the 6 guilty codes. Okay, so MUNCA. Let's try to find out whether MUNCA was even present in the first place in the right hand side table, in the codes table. So let's search for MUNCA. So E, M. Okay, we're in M. There's MR, MUI, MUP. Okay, so LMNOP. So what it looks like is that this row in the merge DF that did not have NaN, that had NaN descriptions, it's not even present. Okay, MUNCA is not even present in the right hand side table. So no wonder why a match didn't occur when we used pd.merge. Okay, similarly, let's try checking for the second guilty code, TRNCA. As I try to check it alphabetically, look, if everything was, mixed, like if it was not arranged in alphabetical order, my life would have been so difficult, right? So that's the reason why I used sorted, so that this list of codes would be in alphabetical order. So it seems we have to check for TRNCA. Let's do that. TRNCA. So there's TRNOA, but there isn't TRNCA. So the fact that a TRNCA from the NAND DF didn't match with the right hand side data frame, which is the sub-R menu code column, makes sense. Same way we'll check for PUEO, TUNCA, and this one, 1, 2, 3, 5 X's. Okay. What you observe after checking each and every value is that none of these 6 codes were present in the codes data frame sub R menu code column. That is the reason why they returned the sub R menu code returned nan. Okay, when you try to produce a match. So since we aren't able to get any sort of matching sub R menu codes and hence matching code descriptions, why, like, if the English language description doesn't exist in the first place, why bother having these 288 rows? Okay, so what I'm going to do, simply because there isn't an English language description for it, I'm going to drop 288 rows. Normally, like, you have to decide whether, when it's numbers, you want to mean impute or median impute, but in this case dropping makes complete sense. So what I'll do is I'll use the tilde, the little wave, to drop um, these 288 rows. Okay, so let's see. I want to bring something to your attention. This particular NAND DF, NAND descriptions for merge DF, it's only a subset, okay, of 4 columns. And I created the subset just so that my life would be, much easier and it would be easier to read. When I'm actually dropping these 288 rows, I shouldn't be dropping it from the NAND DF. Okay, I should drop it from the original raw merge DF. Okay, that is the one with the guilty 288 rows and all the 10 columns, not just 4 columns. So what I'll do instead is I'll make a note of something, just a little comment. And the comment, I'll write it as a markdown cell. So the filter condition that I'm going to apply, saying not is null, I won't really apply it on the NAND DF because NAND DF only contains these 4 columns. I need to apply it on the original DF that had all the 10 columns. Okay, so the original DF that we were working with, that's what this column means. The original data frame that we were working with was actually raw merged DF. Okay, if I'm not mistaken, raw merge DF was created when we used pd.merge. So when I go all the way down, I'm going to mention a subset. So within raw merge DF, I'm going to apply a filter condition. The fact that, and inside the filter condition, I'm going to mention that the column sub R menu code, let me copy this, the column sub R menu code, give me a sec. Is null should not be the case. Okay, so I am going to use the not operator. This is me trying to get the cleaned data frame. Okay, so I'm going to use the not operator. So I'm going to use this little wave right in front of the condition. So the fact that, so the values of sub R menu code basically should not be null is what I'm trying to say. Okay, and this particular result I'm going to assign it to a variable called clean data frame. And let's see, it should be the 6,000, sorry, minus 288. Let's see the shape. Oh, let's see. Perfect. So it was about 6,300 and we removed 288. So it's roughly 6,000 rows, which makes complete sense. Okay. Now we're at the right stage for feature engineering. This was data prep, it's true, but we do have a feature engineering stage. And I want to let you know why I'm doing this. Okay. By the way, feature engineering is a part of data prep. What it refers to is using existing data. So we've got a bunch of columns. Let's just look at the head for clean DF. Okay, this is what we have with us. What's interesting, especially to answer the 5 business questions that we have, there was, delay minutes. There was which is the most frequent hour of the day. So what I'm trying to mention is the fact that date time is something we'll have to work with, is something we'll have to extract. However, the way the data is present right now in the form of 2 separate columns and in not so compatible data types, that needs some working with. Okay. So I'm going to try to do some feature engineering in order to extract time-based components from the existing columns, date as well as time. Okay. So what I'll do is I'll add a header, not a header, sorry, I keep sorry. And the reason why I'm trying to modify the date time columns is because I want to extract certain components of the date so that it'll be easy to create plots, to create charts. Okay. So let me try to see whether the date column and the time column that exists in compatible data types. Okay, so let me do whatever clean df.info. Let me use the info method. Okay, so we're looking at date and it says it's a date time, which is great. And why do I say it's great? Because when an object is of the date time data type, you can use an accessor called DT. So dot DT will help you extract whatever component of time you need. Maybe you need the hour of day. Maybe you need the day of week. So if you have the dot DT accessor, which is possible when you have an object of the date time data type, then your life becomes simple. So the column date is workable for us. So good. The column time, however, is an object. An object is very similar to a string. Yeah.
If you were to call up just column, let's say just the first row of column date time, so that single cell or list element, I guess, whatever it is, and would you have a time element to that? That's essentially 0, 0, 0, 0, 0, 0.
Oh, what I'm trying to do actually is I'm going to try to concatenate the date and the time column so that the resulting value appears in the YMDHMS format. So
But is that the format that the date column is in already? We just don't see the hour, minute, seconds.
Is it already?
With that essentially,
I would, my guess would be no, because the way it's provided in the open data set is that the time component, which is HMS, is already there in a separate time column. So I guess that's why they sort of arranged it that way. So I don't think that this is 1st Jan 2021, 0 hours, 0 minutes, 0 seconds. I think that this is 12:33 a.m.
okay, so
Yeah.
daytime objects do not
Yeah.
do not automatically require the whole setup of date plus time.
That
Yes, but that one's an object date time, or maybe not object, maybe a single the wrong term, but
A data type, date
data
time.
type is date
Yeah.
time. It's okay.
So yeah, I guess I understand what you're trying to say. Like the data type is date time, but you don't visually see a time component in it. Like, yeah, I get what you're saying.
versus just a date, because a date is also
Yeah. I get what you're saying. I guess in this case, I don't know how it was formatted, like in the original data set, what was there on the open data site. But
we call that single cell, like that data frame, row 1, column 1. I'm not having to show up in Jupyter.
let's try to find out. I mean, you know what? Even if we use the type column, type method on that specific. Okay, forget type. Let's try to extract just that one. So what is it? Clean df. Let's try to see. It's the first one, right? And within that, we're interested in the column date. So let's see how that turns out to be. It says, you're right, zeros. There's a lot of zeros at the end.
So it's essentially.
But that's not like in terms of data accuracy, like, that particular delay incident, you wouldn't go by this 00. You would actually go by the value mentioned over here, which is 12:33 a.m. Yeah, but it's good that you asked this question. We were able to actually isolate this particular element and see that it is recorded as 00. Like the HMS is all zeros.
It's probably a number of seconds after.
Yeah.
Probably recorded as a number of seconds after an arbitrary point in time.
Maybe. Yeah. Good question. So, so here, what I want to do, or what I want to be able to do, is I want to be able to combine. Now over here, I have information in the YMD format. In the second column, I have information in the HMS format. I want to be able to combine it, not have it as two columns, into one column only, so that I can use the .dt accessor on that one column and be able to extract different components. So let me show you what I would choose to do next. So basically, I'm going to try to combine a few things. This may not be. Okay, so I'm going to try to combine two columns. One is called date and one is called time. And the topic we're in is called feature engineering, right? So we're going to create a new column. So I would end up using something like cleaned df. So that's the data frame we're working with. And I'm going to name a new column, maybe date, time, combined is equal to something. So whatever transformation I'm going to do, I'm going to assign the values to a new column called date, time, combined. So the other thing I wanted to mention is when you're trying to concatenate something, so you're using the plus sign, concatenation only happens with objects like string data types. However, in case of dissimilar items, like in this case, date time, concatenated with object, that's going to throw an error. So what we need to do is, because we are trying to perform a concatenation, we're going to convert these two into string data types. We're going to convert date and time into string data types, perform the concatenation, and then the concatenated result, the concatenated result, that I'm going to typecast it into a date time object and then use the DT accessor. So what I will end up doing is the date data type, sorry, the date column. Let me do it. The date column. I am going to forcefully, I'm going to typecast it into a string because strings are what can be concatenated. And this stringed value, if I can use that word, so the stringed value is what I will assign to the same data frame. Okay, so now the date column will contain string type objects. I'll perform a similar operation for time, for the time column. So just that this one will be time. Perform the same operation, just that it will be time. Okay. And when that happens, you might get some sort of warning, but it's okay. And I guess there was a person who, the guy in gray, second last row, was this the kind of error you encountered? A value is trying to be set on a copy of a slice. Yeah. So I came in. Sorry, it's a warning. Sorry. Yeah, it executed, so it's not an error. There's a number over here, but yeah, I think this was the thing we were trying to talk about. Perfect. So now that we have typecast both the columns into type object, let's see whether this has actually taken place. I mean, the effects have actually taken place. And it shows that date is now an object and time is also an object. So that's good. Now that we have both these columns as objects, it's going to be very easy to concatenate them. So how do I concatenate? Just use the plus operator. I'm going to access clean df date. I'm going to use a plus sign. I'm going to insert a space as well. And then I'm going to access the value of time. Once I have this, I need to make sure that this resulting value gets stored in a new column, feature engineering, called date time combined, And this column date time combined is part of the same data frame that we're dealing with, which is clean df. The other thing I need to make sure is that this particular value of date time combined is of the data type date time. Okay, so I want explicitly the YMD format. So let's enforce that using pd.toDateTime in the front. So the result of this, I am going to make sure it's of the date time data type. pd.toDateTime. This is the first argument, and the second argument, I'm going to specify the format. So YMD is going to be mentioned here. Let's see, can I do this? Format is equal to YMD HMS. Okay, let's try it like this. And then there's a space that we inserted, H:(M:). Now, in terms of the business, I mean, of course, you can write a %S. There is no harm in it, but in the context of the business questions that we have to solve, there is no need for a seconds column. Like I'm not going to have to use a DT accessor to extract seconds. I need minutes for sure. I need the hour of day 100%, and YMD is always important. So what I'm going to do is I'm going to make a decision to not write, the S in HMS. So I'm going to stop. Yeah.
Sorry, another question.
Yeah.
The format you're specifying there is the format that the object will be created with, or the format that you're specifying to the PD.toDateTime?
Can you repeat the question?
Yeah, so the function that you're using is pandas 2_datetime,
Yeah.
right?
Yeah.
And the format is the format you
It's
want.
a format is an argument for to date time. So
Okay.
that's what I'm trying
So
to.
that's what you're trying to do. Okay.
Yeah. Perfect.
And it will automatically detect the format of the concatenation?
Yes, it will.
Okay.
Yes, it will. Because when you try to check for the results, you will see a new column called date time combined of the date time data type. And when you try to view the value as such, maybe use the head, but not to, oh, you know what, you can actually use that. Let's use head and just to, you will be able to see it only. Hey, one second. So what happened is, I guess it just inserted 0 in those cases for seconds. I can take a look at more maybe. Let's see. Let's see if it inserted 0 for many of the rows, because I didn't want a seconds. Yeah, I didn't want a seconds, so it inserted 0 every. It inserted a colon, but it made sure that the value was 0. Colon for seconds, but it made sure the value was 0. Because I only wanted to, yeah.
Must be integral to the data type.
Yeah, I guess. So now that this has happened, time to perform some feature engineering using the DT accessor. Okay. So what I will do is work on this data frame, clean df. Sheesh. Sorry, this one. Okay, that's not working. And there are specific columns that I want. The column that I want to work on is the daytime combined column, the one that I created just now. So let me copy this. It's getting me. I would want to extract the hour out of the different values of daytime combined, because there was a business question pertaining to what's the hour of the day where the most delay incidents occur. So I'm going to use the DT accessor and write dt.hour, and the extracted hour, I'm going to assign it to a new variable in the same data frame. And that variable would be called, let's just call it hour. Let's just call it hour. So the way we extracted hour using the DT accessor, let's extract the month, because there was a line graph pertaining to the month. Let's try to extract the day of the month, maybe, the 15th day of October, that kind of thing. And there was also a business question pertaining to, I guess you could create that business question. Which day of the week do you find most delay incidents in? Is it maybe a Saturday, which is a weekend, or is it on Monday, because that's when the work week starts? You could create that business question, and in order to answer that question, you would have to extract the day, like Monday, Tuesday, whatever. And how would you do that? There is a dt.day of week that you could use. However, there's a mapping that you need to be aware of. In Python, Monday is denoted using the number 0. Okay, so 0, 1, 2 means Monday, Tuesday, Wednesday. So if you see a 0, that means Monday. So what I'm going to do is feature engineer 3 columns. I mean, I already did the hour. I'm going to do 3 more. This one, day of week. When you use the DDE accessor to extract the day of week, if you see a 0, it pertains to Monday, and you should count from then on. And the value, I'm going to store it in a column called day number of the week. When I execute this, okay, I am now going to try to find out what this looks like. Cleaned df.head, maybe just 3 rows. I want to see all the feature engineered columns. Here you go. Now, let's verify whether all of this makes sense, okay? Like whether what is extracted in hour, month, day of month actually is right. So out of the value of date time combined, so this is 1st Jan 2021 at 12:33 a.m. The hour was extracted as 0. This makes sense, okay? The month was extracted to be 1. This makes sense. The day of the month, it's the first day of January, right? So this makes sense. Also, day number of the week, it says 4. Now, if you go by that notation, like 0 pertains to Monday. So 0, 1, 2, 3, 4. So Monday, Tuesday, Wednesday, Thursday, Friday. So 4 means a Friday. Now let's actually check whether 1st Jan 2021 was indeed a Friday. Okay, 1st Jan 2021. Let's check the day and see whether the DT accessor actually worked properly. And the answer is yes. Okay, it's the answer is Friday. So the number that was extracted inside the day number of week column is indeed correct. So you could use it to answer a business question that, hey, which day, is it Monday, Tuesday, whatever, had the most number of delay incidents over the entire year, over the summer, whatever, or over a quarterly period, etc. Now we are in the very last, what do you say, process of data cleaning for this data frame, and it's creating a delays data frame. If you remember the slide, at the very end, I applied a filter. There were some questionable rows, or rather questionable values. There were some rows where the gap, the minutes of gap was 0, or there were some rows where the minutes of delay was 0. So what I'm going to do is I'm going to actually make sure that they are not there, okay? Or just make sure that I only retain those rows where the gap minutes is greater than 0 and the delay minutes is greater than 0. That's what I'm going to filter for. So the symbol for logical OR is a vertical line, okay? So I'm going to I'm going to mention one filter in a pair of parentheses, the logical OR, followed by the logical OR, followed by the next filter. So what I'll do is I'm going to create a delays data frame. And this is the very last step, okay, of the data cleaning process. And the filter that I'm going to try to apply is over here. Okay. Oh, my bad. Okay, let's try this way. Somehow my shortcuts aren't working. Okay, so these are the 2 filters I want to apply. Make sure that the minutes are always greater than 0. So for that, work with a cleaned data frame. Subset only for rows which satisfy these 2 filters. So for that, I'm going to apply 2 filters and make sure that I'm creating a new data frame called delays data frame. And hopefully the number of rows now are much less than 16,000. Let's see. Delays df.shape is down to 7,000. So remember, we started with 16,000 incidents of delay, and we are down to about 7,000 incidents of delay. Okay, so during the data prep stage, a lot of data may get filtered out, and that is completely normal. So I guess now that, you know what, let me just do a little head function. And now we can actually start with the business questions. Okay, now let's proceed. This is the very last section, and I guess this is also the quickest section, which is answering the business questions. I'm going to just make a quick note of the 5 business questions. Okay. Sorry, guys, my trackpad isn't working too well this time. I just made a note of the 5 questions and will answer the first one. Let's do it this way. What is the average? So the first question is, what is the average delay in minutes over each month? So we have extracted a month column, and we are going to definitely make use of it. The other thing is, we're asked about the average delay in minutes. So the other column we'll have to work with is the delay minutes column, So we already pinpointed 2 columns that we have to work with. And now we're going to make use of the group by function. Okay, the group by function. So what I'll do is I'll work with the delays data frame. So df.group by, and what am I trying to group by? It says average delay over each month. So what I'm trying to do is all the rows pertaining to January, I'm trying to group those together. All the rows pertaining to February, I'm trying to group those together. That way over all the 12 months. So inside the group by, I'm going to mention a parameter called by, and inside that I'm going to mention the column name, which is month, because I'm trying to group by month. Once that is done, see, you can't just write the column that you need to group by. You also need to mention a function, like an aggregation function. Maybe the rows that you aggregated by, you need to find out, the count of those rows or the average of those rows or whatever. So you need to mention some sort of aggregation function. So what I'll do is I'll revisit the question. It says average delay. So what I'll do is I'll use the mean function. Okay. So what I'll do is I'll mention dot mean. So I'm grouping by the month, and I'm making sure that I'm using the mean function over what? Mean function. So yeah, the mean function over the delay in minutes. Now, which column does that pertain to? Delay underscore minutes. So I'm going to mention this column name in square brackets. Okay, so grouping by month, what am I trying to do? Finding the mean minutes. So January, I'm grouping all the rows. Sorry, there are different values of delay minutes for all those rows. Take the mean. So mean for January, mean for February, mean for March, and so on. So once you have this, now it all depends on your imagination, how you want to make your plot look. You might want to put some markers. You might want to add some color, things like that. So you can use the dot plot method. And you might want to put some markers as asterisks. Okay, so I'm going to write marker is equal to asterisk, and maybe you want all the values along the x-axis to be at a certain incline. So rotation equals 45 degrees, and this particular group by, or rather this particular plot, it's always, best when you try to give some name for the x-axis, y-axis and all that. So I'm going to say PLT because matplotlib pyplot, we put the alias as plt.title, and you can give it a title of average delay duration per month. Then now that we've created a chart title, we can name the X and Y axis. So let's have a look. 1 second. List object, sorry, has no attribute mean. Let's check group. Oh, sorry. By should be over here. I'm sorry. Group by itself is a function. So I should have closed the brackets. Then outs, yeah. Group by itself is a function. So I should have closed the brackets. Upon the group by, I'm finding out the mean. Okay, so this, fine. So over here on the x-axis, I have month and the y-axis is unnamed. So let me, modify it, make it look better by adding an X label and a Y label. So now you can see asterisks and you can see the x-axis is named as month and the y-axis is named as minutes average. So with this, the conclusion that we can draw, how we can answer this question is that on the 5th month, which is May, you have the highest average delay. And the lowest delay is during the month 9, which refers to September. So we can make a note of that. So here it is. Okay, the average delay is the longest in May at 9 minutes long and shortest in September, which is roughly 5 minutes or maybe 5.8 minutes. Okay, the next question was the most frequent causes of delay. Let's see, most frequent causes of delay. We are now on question number 2 and we will complete very soon. The most frequent causes of delay. So what we'll do, let's just check our data frame, cleaned, delays df, and let's just do an info. I just want to find something out. If you're talking about cause of delay, you definitely want the English language description, because abbreviations, we just can't work with, like we don't understand it as lay people. So you definitely want to work with the English language description. So let's see. Code description is what I'm going for. Fine. So this is the column I need to work with. So I'll group by the code description. So all the rows pertaining to brake failure are grouped together. All the rows pertaining to AC problems are grouped together. Okay. So I'll write df.group by and the name of the column, which is code description. And then dot. What do I need to do? Most frequent cause of delay. Most frequent refers to count, like brake failures. 93 incidents caused by that delay. So you want to work on counts. So what you'll do is you can use, and count is an aggregate function, right? So let's see. I do want to mention, like, I know you're going to see inside aggregation, when you write .agg, you mention a dictionary. So dictionaries are enclosed in curly brackets. And how do you mention values inside the dictionary? It's always in the form of key value pairs. So key, colon, value, commas, okay? So let's see, in the key, what I'll do is any column that has all values. So for example, the delays data frame has 7,300 rows. So any column that has all the 7,300 rows, I can take the count of. Okay, I can take the count of, but I should not take any column that has less than the 7,300 rows. So I shouldn't take bound to group by. I shouldn't take line either because this is 3 less than the total values. So once you've grouped by the code description, find the count over any of the columns that have no missing values. So in this case, maybe I could even do station, doesn't have any missing values. So once this is done, what are we supposed to do? We're supposed to find the most frequent causes of delay. Okay, so another thing we could do is, this is a dictionary, right? So using commas, you could find, so it's delay, right? So you could find the median value of delay minutes. So the delay minutes column, you might want to find the median value over such groups. Now, when you do that, the other thing is you want to find out most frequent causes of delay. So you're referring to count, but when you do the group by, actually when it will be mentioned as the value that you aggregated. Sorry, it'll be mentioned as the column name that you aggregated by. What I'm trying to show you is this. It'll show station 66. So you see, these are, RCS equipment related 7 incidents. But what is this showing? It's showing us the name station. It's still showing us the name station. So you know what you can do in Python, you can chain functions, like you can use a group by dot aggregate dot rename as well. You can chain multiple functions. So I'm going to use a dot rename so that this word station actually reflects, number of incidents or count or something like that. So what I'll do is dot rename, let me write here, columns. Which column do I want to rename? I want to rename the station column, and this is again dictionary, so key value pair. I want to rename the station column to be more reflective of what this actually is, which is the number of delay incidents. Okay, I want this to be more reflective of what it actually is. So now that we've renamed it, another thing that I observe is the counts are not really, see, the question is most frequent causes of delay. So you want the number of incidents to be in some sort of order, preferably descending. So, but this is a random 66, 487. Ideally, you want the bigger numbers on top. So what I'll also do is I'll make sure that I save this particular result, and then I work on this result further using sorting. So I'm going to say delay types df. And then I'll mention that it's on this delay types data frame that I want to sort the values. How do I want to sort the values? I want to sort the values based on this column. By the way, I renamed it number of delay incidents. So I'm going to say by is equal to column number of delay incidents. And how do I want to sort it? In a descending fashion. So I will say ascending equals false. I'll say ascending equals false. And let me put a comma here. Ascending equals false. This is to show the values in a descending fashion. And the other thing is, see, there are 123 rows, 123 delay causes of delay. I just want the most frequent cause of delay, right? So I'm just going to filter for only a few of those delay codes or those delay descriptions. So I'm going to use head. You can do top 5, top 10. I'm going to choose top 10. And now let's see. So this shows the top 10 delay causes. Disorderly patron is right at the top with 1,000 plus delay incidents caused by it. Okay. So the answer to the second question is disorderly patrons are the most frequent cause of delay at about 1063 incidents. Now, third question, and the third question is too simple. In fact, since I literally typed the code for the previous two questions out, the third question you can actually copy paste from your previous cells itself, okay, from the answers of the previous two questions. The third question is, which is the cause of delay that results in the longest delay? Which delay description results in the longest length of delay? So let's find that out. For that, I'll again work with this delay types data frame because it's been worked on pretty well. So delay types DF already exists. So here, the only thing is, when I've applied the sort values function, instead of sorting by the number of delay incidents, this time I'm going to sort by the delay minutes. Okay, I'm going to sort by the delay minutes, and that I'm going to sort in descending order. So I'm literally copy pasting my answer from the second question, okay, with a small modification. Instead of saying sort by number of delay incidents, I'm going to say sort by delay minutes. Sort by delay minutes. Descending order, top 10, and we should have the answer right now. Yeah, it was. So it shows that it's when the train is in contact with a person, that is when the delay minutes are the longest, roughly 1.5 hours. Okay, so we've gotten the answer to the third question. Let's write it down and jump to the fourth question. We end at 4:10 now, so 10 more minutes, but I don't need that much time. The second last question, which hour in a 24-hour cycle, in a 24-hour day, during which hour does the highest number of delay incidents occur? Now for this, it's very, it's very easy to compare it when you have the 24 hours as 24 bars in a bar graph. So let me use matplotlib and create a bar graph. For that, I have to first group by the hour, and I already have an hour column created in the delays data frame and all. So what I'll do is group by the hour column. So all the delay incidents pertaining to the first hour of the day are grouped together. All the delay incidents pertaining to the third hour of the day are grouped together, that kind of thing. So this is what I'm going to write. This is the group by I'm going to write. And once I've written the group by, it says during which hour does the highest number. Number refers to count. So once the group by is done, the aggregation function I'll mention is count. And once the count has occurred, I have to mention a column as well. Any column that's not missing all the station. Okay. I've done the group by with the aggregation. And now what do I need to do? I need to plot. So I'll write PLOT. Kind is equal to bar. Once that is done, maybe I should add some x-axis, y-axis and all that. So let me do the same. And check. Perfect. So it seems that it's during the 15th hour, which is 3 p.m. and the 17th hour, which is 5 p.m. that the highest number of delay incidents occur. Okay. So, and this is, throughout the year. So it's the cumulative count of, overall the year. Over all the months of the year. So 3 p.m. would be roughly at 450 delay incidents. 3 p.m. the delay has occurred. Okay. Now we're at the very, 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 very last question, and we will be done in a minute, well inside 4:10 p.m. So the last question was pertaining to the terminal stations, which are the specific subway stations on the TTC that have the highest number of delay incidents. Now, the format for all of this was already laid down in the previous answers. So I'm actually going to copy paste from my previous answers. Okay, so what I'll do is I think this was answer 2. Yeah, from the second answer I will mention, I'll copy this. We already have a delays df, no? So let's see, delays df dot group by. Let's copy this. So delays df dot group by. So it says which subway station. So I need to group by the subway station. So for example, Finch subway station, all its delay incidents. So let me change this, the station, and you're trying to find out. Yeah. So the aggregation is count over the station column. And highest number of delay incidents. So let me find out the median value. Oh, sorry. Yeah, let me find out the median value of delay minutes. And in place of station, when you actually display the group by result, in place of the header station, what I want displayed is number of delay incidents. Yeah, that's fine. So I'm going to save this result as delays by station or station with delay. And let me see. I will have to sort this. Sorry, I will have to sort this particular result. Yeah, it says, yeah, it's in random order, right? So like 57 is on top, 59 is down, 1 is all the, yeah. So I'll have to do df dot sort values, sorting it by what? By the value of number of delay incidents in a descending fashion. So ascending equals false. And I only want the top stations, so I guess I'm going to write head. Okay. And dot HEAD, maybe top 10 stations. Let's do top 8. Sorry. DF dot sort value stations with delay by number of delay incidents. Let's see, ascending equals false dot head. Oh, sorry. Num of delay incidents, num of delay incidents. Okay. Okay, I should remove the hyphen. And 1, 2, 3, 4, 5, 6. Wait, 1, 2, 3, 4, 5, 6, 7, 8. These are the top 8 stations with the highest delay incidents arranged in descending order. Okay. So with this, we actually complete our analysis 4 minutes ahead of schedule. That's not a delay. That's not a delay. You got me, like, the whole data set was about delays, and yeah. And I demonstrated what's not a delay. Yeah. Okay, guys. So I hope y'all were able to extract value out of it. You'll learn some methods to answer business questions. And if you all want to work with the code, this particular URL will always like, I'm not going to take it down or anything from GitHub, so you can always refer to this anytime you want. And Let me see if I can pull up the PPT. You can connect with me on LinkedIn if you have any questions or if you want to discuss other data sets or other methods to work with data sets. I'll be more than happy to have such discussions. Okay.
Exclusively work with Jupyter, or do you use other tools as well?
My data analysis is usually done in Jupyter. Yeah.
So Jupyter, as you used here,
Yeah.
is web-based.
That's right.
How do you organize?
Like PyCharm or something. I mean,
Yeah,
you're talking
I mean,
about.
I'm thinking even if you're bringing in data, like
Huh.
what's your, are we talking about a working directory?
Right.
Or where to look for data, whether you're using.
Like if I had streaming data, how would I really work with it? I'd create .py files, and usually the kind of platform, or yeah, I usually use PyCharm for those kind of things. Like I have worked with telematics data before, where you have GPS trackers attached to vehicles, and every 10 seconds you have streaming data. So for that, you definitely are, I mean, you can extract a subset of the data, like that's just a small point of snapshot of time, and analyze that in a Jupyter notebook. But ideally you are going to work with such things like using like a normal Python script, yeah. So that sort of that sort well, it was actually running on a server. I mean, yeah,
Yeah.
the company server.
So the .py file is essentially a file that contains data.
It contains all the data to pull. Like, say for example, like in this particular case, I was working with the open weather maps. I think that's one API. Then there was also one pertaining to the Ontario 511 API. I think that's the API that gives you at at intersections, like, so there's latitude, longitude, if there's any road work going on, if there's any construction. Exactly. So that is also real time. So that kind of data, like pulling it from an API, also I had to connect to those GPS trackers and collect data every 10 seconds, store it in a MySQL database. And before storing it in a MySQL database, I had to apply a lot of transformations. So all these things that I wrote inside separate cells in a Jupyter notebook, I actually first tested them out in Jupyter, and then I combined them all and wrote it in a proper script .py. Yeah.
Notebooks is a really great way to troubleshoot.
Exactly, troubleshoot, or just like focus on a small segment, like isolate the case and understand that more. But when you're talking about something in production, then you should look for something bigger. Yeah.
Interesting.
Yeah.
The similarities between Python and R are just shocking.
Yeah.
It's almost a wonder that there are two parallel streams.
And how do you use it in R? Like, for example, if there's a bunch of analysis you've done in R, because I've not worked too much in R, but you have. So how do you then run it in production?
Honestly, the Jupyter notebook thing is quite neat, where you have these chunks. But so I would.
There are R scripts,
Script to do a process similar to this, so clean data, extract, and potentially even display in some way.
Yeah.
I would load my data using an almost identical sounding tool, read.csv or read_cv, in a package, or maybe in innate and a native tool, pointing it to the location on my hard drive.
Yeah. Okay.
Right. Yeah. I'm not aware of methods where you can like this. I mean, Jupyter can run R, right?
I think it can. Like, 1 second. This one's a IPython kernel. I haven't downloaded R on my machine, so maybe it doesn't appear as one of my drop downs. But let me see. File. Yeah. But I know of a way where this particular thing turns into R.
There is it. Okay.
Yeah.
Yeah. So maybe you could do the same thing.
There's a way you can execute SQL in Jupyter as well. Like, yeah, the integrations are all available. Yeah.
So anyway, I ended up running, individual lines of code or individual ifs or for loops or whatever, to isolate a problem or to create iteratively.
Yeah.
Yeah, it's super cool. Yeah, very neat. I mean, otherwise you're working off of GitHub and you're doing push pulls and they may be asynchronous, so you can't see the other person's
Exactly.
work in real time.
Exactly.
And then you may have merge conflicts.
Yeah.
And then you know how irritating those are. This is a cool tool.
Yeah. So do you use RStudio normally, like whenever you have to?
Pardon me. Yeah, I use our studio for development. And then almost everything that I run these days is either part of a package that can be exported and loaded on used machine, or it scripts using our in-house tools and other packages that are triggered by Windows Task Scheduler and run in the background.
That's right.
On the R executable.
That's right.
So, but our
Perfect.
studio I don't see why you would code outside of our studio.
Yeah.
Just R. But
yeah, we used to run cron jobs in order, like on in a Linux environment, in order to execute something at a certain frequency. Yeah, cron jobs.
Yeah.
Windows
So-
start scheduler, very similar. Very similar. Yeah.
You
Okay,
can also
guys.
use Jupyter notebooks in our studio.
Okay, that I did not know. That I did
Well,
not know.
I just saw the option.
Oh, cool.
Maybe I can write Python in our studio. I don't know why after the see this.
Anyways, I hope that this provided a lot of value for you all. And I don't know about, like, there are certain languages you may be already familiar with, so you don't have to make the switch to Python, but I hope in a general sense, it does encourage you to work with the field of open data, like that sort of exploration. I hope I've given you some sort of impetus for or incentive for. So yeah, feel free to connect with me on LinkedIn. Renna Shaw is my name. So that's, I think, this is the same profile picture I have on LinkedIn. So yeah, you'll find me in that black and white picture. Okay, guys. So shall I stop sharing the screen? Okay. Thank you for all the people watching virtually. Thank you so much for following us so far. Feel free to connect with me on LinkedIn. My name is Renna Shaw. I can write the spelling down if you'd like. It's RENASHAW. And I may have it opened up. Let me see. If it's not, then find me with this black and white picture. Okay. Bye, guys.